Hello students, in last video we studied about the combination reactions where two or more reactants combine to form a single product. Today we go for the decomposition reactions where a single reactant breaks down into two or more products. So the reactant is always one, but the product may be two or more always. Actually, the decomposition, we have three types of decomposition reactions. First one is thermal decomposition reaction, second one photo decomposition, third one is electrolytic decomposition reactions. First one we can go for thermal decomposition reaction. So the thermal name itself says by supplying heat energy we actually break down a single reactant into two or more products. So we can just go for two or three examples to study about the thermal decomposition reactions. Thermal decomposition of lead nitrate. Lead nitrate is a white colored salt. So when we heat the lead nitrate, PbNO3 twice. When we heat it, so we just show with a triangular mark, heating with a small test tube, we get the brown fumes of nitrogen dioxide, so here, and a colorless oxygen gas along with lead oxide, which is a yellow residue. Okay, so we get PbO, lead oxide, brown fumes of nitrogen dioxide and oxygen gas. Both are actually evolved here. We can just balance this equation now. So this is the equation which we actually balance. So lead nitrate is white in color. You should know the color of the salt also. Lead nitrate crystal solid, which is white in color. On heating gives you lead oxide solid, which is yellow residue we got in this equation. Nitrogen dioxide, reddish brown fumes, and oxygen is a colorless gas. This is a very good example for thermal decomposition. Lead nitrate on heating gives you single reactant and three products. It's a very good example for decomposition reaction. One more is thermal decomposition of ferrous sulfate crystals. They gave you in the NCERT textbook. So ferrous sulfate, FeSO4, 7H2O. This is actually a hydrated salt which is having pale green in color. A pale green hydrated salt, ferrous sulfate. On heating, actually it loses the water of crystallization. We call this as water of crystallization. FeSO4 plus 7H2O. Water gets actually separated now. It is actually colorless now. Now it is colorless. Still on heating this, water gets actually evaporated. Still on heating the ferrous sulfate, FeSO4, what we get is actually ferric oxide, Fe2O3 plus sulfur dioxide plus sulfur trioxide, which is actually again reddish brown in color. You should know the color also, reddish brown, and these two are having actually the smell of burning sulfur. We can just know about this smell also. Ferrous sulfate on heating first get converted into colorless FeSO4. Still on heating, so we get a reddish brown ferric oxide, sulfur dioxide, sulfur trioxide, which both are actually having the smell of burning sulfur. Next we can go for thermal decomposition of calcium carbonate, which we call as a limestone. Common we call it as limestone, calcium carbonate. Common name is limestone and the chemical name is CaCO3, calcium carbonate. On heating gives you calcium oxide and carbon dioxide. We call it as a quicklime. So this is called as quicklime. So these three are the examples they gave you in the textbook, and very important also, all these are examples for thermal decomposition. Photo decomposition reactions. The decomposition reactions where sunlight is used for the reaction to take place. So here we can take the example of photo decomposition of silver chloride and photo decomposition of silver bromide. So let us say photo decomposition of silver chloride. Silver chloride, when exposed to sunlight, so silver chloride which is solid, the color is actually the white, and once it is exposed to the sunlight for some time, for about 1 or 2 hours, slowly the reaction takes place. We get grey colored silver and the chlorine gas is actually evolved. This is the reaction actually which takes place during the photo decomposition of silver chloride. Silver chloride, sunlight exposure gives you silver and chlorine. So chlorine gas escapes out, we get white colored silver chloride turns into grey colored silver. Next, photo decomposition of silver bromide. AgBr, which is solid, here it is solid and it is gas. So on exposed to the sunlight, previously silver bromide is yellow in color, on exposure to the sunlight gets again converted into grey colored silver, and again bromine actually is evolved here. So in this case also the yellow colored silver bromide gets converted into grey colored silver. These two are very good examples for photo decomposition reactions. Next one is electrolytic decomposition of water. Water is a very stable compound. So to decompose water we always need electricity. So water, as you know, is a bad conductor of electricity. So actually we will take the water in a plastic mug. We can actually prepare this type of actually the electrolytic chamber. So we can just use the 2 test tubes here, and we will take the water. I told you water is a bad conductor of electricity. We will add just a few drops of dilute sulfuric acid to make it a good conductor. So next what we do is we just fit the 2 graphite rods as electrodes here, and you can observe here these are called as anode and cathode. So cathode means the actually electrode which is fitted to the negative terminal of the battery, and anode is the electrode which is fitted to the positive terminal of the battery. We can take the 6-volt battery here, and once the switch is actually closed, electricity starts flowing in the liquid. Now electrolysis takes place and water slowly decomposes into hydrogen and oxygen. So actually hydrogen forms a positive ion, so it will be actually we get it at the cathode, and oxygen we get it at the anode, because oxygen always forms a negative ion, so we get it at the anode. So the total volume of the oxygen gas which is produced is always half of the hydrogen produced. As you know, the volume of hydrogen is double compared to the volume of the oxygen in this case. So actually this is mainly because in water we have 2:1 ratio hydrogen and oxygen. So that's why this electrolysis shows that the hydrogen and oxygen present at the ratio of 2:1 by volume, so in water, and this is an example for electrolytic decomposition of water.